Hi, I'm Matt, back with another AI back-office automation use case. This time, we'll be putting together a claims agent to handle inbound customer claims regarding recent purchases as part of the series, Your Employee of the Month is a Robot. Did you know that 16.5% of all e-commerce purchases end up returned? And of those, 20% are returned due to damage. An averaged $10 million e-commerce business handles roughly 13,000 damage returns per year. So let's jump right into the problem with a hypothetical use case. Your CEO has set a company-wide goal to automate away all repetitive and manual tasks. At an all hands, you throw out the suggestion to build your first automation robot. The CEO agrees to your suggestion and asks for a proof of concept. After a few weeks of user interviews, process mapping, and discussions with your team, you've picked a narrow use case as a candidate for your first automation. Now, despite stellar customer reviews, 1% of orders sent to customers arrive damaged. As the business grows, this 1% has become a back-office nightmare. The process involves handling inbound customer emails, verifying photos with damages, checking warranties, making decisions, and responding to customers. This sounds like the perfect problem for our robot. To build a rapid prototype of our solution, we'll use n8n for the workflow, Outlook for emails, OpenAI's latest model for reasoning with vision, and an integration into our e-commerce provider. All right, so here's our entire n8n workflow. If we zoom into the beginning here, we need to start off by retrieving our emails from the Outlook server. We have a schedule trigger here that will routinely kick off this workflow, a configure set that holds a couple of variables, our base URL for our e-commerce endpoint, as well as an API key. We've got a get messages node, which is an Outlook node. This node will filter out any new emails in the inbox that have been unread as well as categorized as demo. So you'll see that in the bottom section here under the filters area. We then strip that email for its HTML tags so that we have a nice clean message to pass to OpenAI later. Now on to the claims agent. This is where we set up our OpenAI call. Because our claims agent will need to know how to use several different tools as part of its workflow, we define that into this code node called tools. We also set up a system message which holds all of the instructions for the robot to accomplish its job. First, let's start with the system message. In the system message, you'll see that there is a prompt that asks the large language model to act as a claims representative and that they have been tasked with the following 5 steps. They need to verify that the photo shows defects, that the product is still under warranty, and decide if a replacement should be shipped to the customer, and then email that decision back to the customer, and then terminate. And 3 bullet points for the rules of engagement. They need to stick to the procedure and not invent their own, stick to the role and politely decline off-topic questions, and do not output messages, only call functions. And so this rules of engagement is important because large language models tend to hallucinate. Maybe that'll be corrected in future models, but as of today, it is important to try and rein in the ambitions of some of these large language models so they stay on task. All right, so now that we've defined our process manual, let's take a quick peek into the tools. Here we define the functions that our large language model will need to access in order to accomplish the tasks listed in the process manual. Verify order, review photo, verify warranty, and then email customer. Great, so all of that information gets packaged up and sent to OpenAI. Here we're just using a standard HTTP request node. We're not using the dedicated OpenAI node provided by n8n. We're using GPT-4 Omni. Here we pass tools and a few other values. All right, so now let's jump right into the tools area. So the way that our robot will work is based on the process manual we've defined, it will decide on its own whether or not it should use a function or a tool. In our case, we've allowed it to call tools in parallel. This is a feature provided by OpenAI and works nicely. So what we do next is set up the tools for our robot to access. If the large language model wants to call a tool, we do that here by checking if part of the response includes tool calls. We also have a switch node that will automatically redirect the tools to its appropriate function. We've got photo, warranty, and email. And there you have it. This workflow is designed to allow GPT-4 to call these tools in parallel and decide for itself whether or not it's accomplished its job based on the system message or process manual, in our case, that we've provided it. Now let's jump in a little bit deeper into each tool. Let's start with our photo reviewing function. So the contents of our customer email will have a link to an image. What we do here is, using a REST node, we download the image found within the content of the email. Of course, might not be practical in a real-world use case that someone sends a link to an image. There is an alternative to be able to extract binary images from the content of the email message as well. But for simplicity, we'll do it this way. The extract from file node then converts that image into a base 64 string in preparation for an OpenAI call. We have a separate system message asking GPT-4 to act as a product detector for an e-commerce company and asking it to return a JSON whether or not it was able to find a defect from the image that we've sent. And again, we're using a REST node to call OpenAI. We've got GPT-4 Turbo, which supports vision. And we specifically call out the response format, and we ask that to be a JSON object. Moving on to the verify warranty. Here, we're simply calling a REST endpoint to get the order from our e-commerce database. And then we use a code node to calculate the order age. And finally, we have the email customer function, which will format the text GPT-4 will output, put that into an HTML template, and then send that out using an Outlook node, replying to the original email referenced by ID. So what happens after we execute this workflow is the inbound customer email gets sent to the claims agent. The claims agent decides, based on its process manual, which tools it needs to call. It will call these tools in parallel. It'll check for the defect in the photo. It'll check the warranty. Those results get merged into these merge nodes, combined into this code node, and sent back to GPT-4 so that it can understand the outcomes of those function calls. Okay, so let's test out our workflow. I'm going to compose an email with the following contents. Let's say we purchased a book. It arrived water damaged. This is the order ID, the address, as well as the photo link. So we can drop that photo link in here and you can see, yep, there's a photo of our damaged book. And so let's just hit send. So then we need to go into our Outlook and categorize this as a demo email so that our workflow will pick it up. I won't show this part of the workflow because there's some sensitive information in that inbox. So there you go. I've marked it as demo. All right, let's trigger this workflow manually so that we can see it in action. I'm going to zoom in a little bit so that we can have a good view of the loop. All right, the agent's got the message. It's checking the photo, checking the warranty, a second pass to generate the email, and out it goes. There it is. Now let's take a quick look at the email that just arrived in the inbox. Dear Matt, thank you for reaching out. We've reviewed the photo of the book. It does indeed show visible water damage. A record shows that the product was purchased about 20,000 days ago and is no longer under warranty. It's probably because there is no purchase date on this record. Unfortunately, a replacement was not offered because it fell outside of the warranty. Well, that's fair enough. It's 20,000 days old. Well, there you have it. We've set up our first robot colleague, our claims agent, and we're ready to show our CEO. But this is just the beginning. Imagine applying this technology to other areas of your business. How about automating your PPC campaigns? Yep, our AI can help optimize those too. Or maybe you're thinking about automating your inventory management. The possibilities are endless. We're talking about a revolution in the way we do business with AI-powered agents, tools transforming every aspect of back office operation. So if you're ready to make a robot your next employee of the month, head over to our GitHub repo down below. And don't forget to like, subscribe, and hit that notification bell for more awesome content from Dancing Robot Studios. Thanks for watching and see you next time.